Hello, my name is Caterina Vernieri. I'm a particle physicist in San Francisco working at LHC, the Stanford Linear Accelerator Laboratory, and I am part of one of the experiments at the Large Hadron Collider in Geneva in Switzerland, where we accelerate protons almost at the speed of light before we smash them into each other to study the interaction of the fundamental constituent of the protons, the quarks. In 1989, when the Berlin Wall fell, I was not even a year old, moving my first steps in the world, and I've been even more lucky as a scientist at LHC to be able to work without any barrier with the most brilliant minds from all over the world. Nature was and is so mysterious to me. As a child, I want to understand better why the things behave the way they do, why the sky is blue or orange these days. And growing up, I realized that's what physicists do. And as a particle physicist, I can access tools or build new ones in order to understand the universe and its fundamental laws. So my wish has become partially true. I do the job I wanted, but there are so many things yet to be discovered that we don't understand yet. What we know about the physical universe is described as the so-called standard model, which is far from being a complete theory of nature. It can only explain 5% of the visible matter. The rest is made of dark matter, dark energy that are still very mysterious to us. As a particle physicist, I strive to better understand nature. With my colleagues, I'm building new tools in order to observe particle interactions at LHC. The interaction between the elementary constituent of the protons, the quarks, cannot really be observed directly, are almost invisible to us. The way we study them is by reconstructing, analyzing the debris of the collisions of the proton-proton interaction. And my research field in particular is the Higgs boson, which is this particle that we discovered at LHC in 2012. And it's very special because it's responsible of the mass of all the other particles. And it's very rare. We only produce one Higgs boson every 10,000 collisions at LHC. And in the last 8 years, it's taken a lot of work to understand better its properties. And right now, we are busy to understand how strongly it interacts with itself by looking for the production of two Higgs boson. And this can be potentially groundbreaking. Studying with extreme precision the Higgs properties can give us hints of where new physics lies, and we could break the wall of the standard model and open up for a new set of physics laws that can explain the things we can't right now. What is interesting about what I'm trying to measure is that it's invisible, and we need very specific tools in order to observe it. We use sort of giant cameras that record everything that happens at the LHC as a result of a proton-proton interaction. And as LHC, we are building the next generation of the camera that will be installed at the core of the Atlas experiment. And it will have 1 gigapixels, which is a factor 10 more of the current camera, will enable a new era of precision measurement of the Higgs bosons, and potentially it can give us what we need in order to understand more of the 95% of the universe we don't know yet of. Of course, this is not a one-person job. It's a monumental effort. Thousands of people are needed in order to operate and build those cameras. And in particular, as LHC, I work with technicians, engineers, and designers, not just physicists, in order to develop these sophisticated tools. It's too early to quantify or predict the impact that our research at LHC will have. For instance, the World Wide Web was first invented to exchange data between scientists at CERN, and then has changed our lives. Or new cancer treatments have been possible thanks to new technologies developed in accelerator physics. What I'm trying to say is that what we do at LHC is pushing boundaries. What we do has never done before in history. So I'm not sure where we will have an impact, but I'm sure that technology transfer will happen at a certain point. Definitely wonder a lot about what is beyond the standard model and how the exposure can help us finding new ways to explain things we don't understand yet, like dark matter and what gravity fundamentally is. We know how it behaves, but we don't know yet how it does what it does. We don't understand yet the microscopic nature of the gravitational force. My mom probably doesn't still get my job and what I do, but I'm sure she's happy that I've been able to follow my passion and do the job of my dream. Although probably she would have preferred I would have stayed in Italy.